Okay, year 3. It's lovely to see you all. It's been great seeing how hard you've been working on your multiplying and division of 3 and 4, and now you're working towards dividing by 8. So same basic concepts. If you know your 2 times table, you know your 4 times table. If you know your 4 times table, you know your 8 times table. If you know your 8 times table, where you're multiplying values by 8, so 8 times 4 is 32, you know if you divide by 8, you get 8. Sorry, divide by 4, you get 8 plus 8 plus 8 plus 8. So 32 divided by 4 is 8. So 4 times 8 is 32. 32 divided by 4 is 8. So that's called the inverse operation. Next video will show you about that. Today, when we're recapping work we've done in year 1 and year 2, we're thinking about vertices on 3D shapes. Now, vertices is the point where edges of a 3D shape meet. So we'll just recap what we know about the edges on 3D shapes. So having a look at this cylinder, this square-based pyramid, and this cube, I'd like you to think about the number of edges, so the points where the faces meet on each of these shapes. So these 3D shapes, how many edges, so the points where faces meet, do each of these have? I know Chloe's got the first one. She spotted that cylinder's got 2 edges. I know that lots of you, I'm sure Rebecca has, I'm sure lots of you have got that square-based pyramid has 8 edges, and finally our cube, where there's all the faces are squares, our cube has 12 edges. So well done if you've worked through that. Our next one here, we're going to look at our vertices. Now, vertices, to remind you, are the points where edges meet. So if we remember, if we looked at our square-based pyramid, it's got 8 edges. Okay, so 8 edges, but it's only got 5 vertices. So the ones at the bottom on the square, and then the one at the top where the peak of the 4 triangles meet. Here we've got a triangular prism. Now, how many times does an edge meet another edge on a triangular prism? How many times do you think it is? Is it 5, 6, 7, or 8? Pause and have a look. Point to each one on your triangular prism if you can. Well done, guys. Lots of you have spotted now that we've got 1, 2, 3 at the bottom and 1, 2, 3 at the top. So we've got 6 vertices on this triangular prism. Well done, year 3, sorry. Now what you're going to try and do is look at these 3 shapes. We've got a square-based pyramid, we've got a cuboid, and we've got a triangular-based pyramid. With these 3 shapes, how many vertices does each one have? So see if you can spot how many vertices each one has. The yellow, the green, and the blue. How many vertices does each one have? Okay, guys, pause the video while you work through that. Lots of you spotting correctly that the square-based pyramid has 5 vertices. Lots of you spotting that the triangular-based pyramid has 3 at the bottom, 1 at the top, so 4. And therefore, we spot that the cuboid with the rectangle at the bottom, so 4 points there, and 4 points at the top of the other rectangle. Therefore, it has 8. Okay, so lots of you spotting correctly the number of vertices this has. Right, guys. Second set of another question here. I'd like to spot the number of faces. One of these shapes has the same number of faces as it does vertices. So is it that cuboid? Is it that triangular prism? Is it that cylinder? Or is it that square-based pyramid? Which of these shapes has the same number of faces as vertices? So remember, faces are the faces, and then vertices are the point where the edges meet. So which of these shapes has the same number of faces as vertices? Pause the video while you work through that. Well done if you spotted that it is 5 for our square-based pyramid. 4 points at the bottom, and then 1 at the top where the 4 faces that are triangular meet. Okay, Pippa's counting the vertices on a 3D shape. She thinks that the shape has 8 vertices, so it must be a cube. Is she correct? What do you think? Have a chin rub. Is she correct or is she incorrect? Lots of you spotting that she's wrong. It's false. Why is it false? Could it be another shape as well? Or has she counted the number of vertices wrong? When you draw yourself or make yourself a cube or find a cube and see if there's any other shape which is similar to a cube. Lots of you spotting that a cube is also similar to a cuboid. So instead of all the faces in squares, you could also have a shape which has 8 faces, sorry, 6 faces, but 4 of those faces are rectangles, and then it's a cuboid rather than a cube. Okay, guys, we're just going to have this one set of questions today, 5A, 5B, 6A, and 6B. Have a look which ones for 5A and 5B have got the number of vertices. So see how many vertices on 5A and 5B, so the points where the edges are meeting. And then for 6A and 6B, which has fewer for 6A than 6 vertices and which has more than 6 vertices for 6B. Pause the video while you work through that, please. Okay, guys, so 5A, it's a cuboid, so it has, let's see, 8 vertices. Well done. So 4 points at the bottom, 4 points at the top if it was lying flat. For 5B, there's 5 points where the triangular base pyramid has edges which meet with each other and therefore are vertices. Fewer than 6 vertices, it's just our cylinder. It's just our cylinder. And then the shape that has more than 6 vertices is that cuboid. It has 8 vertices. Okay, 8 vertices. Okay. Right, guys, having a look through now our final sheet. This is the sheet that you will have been sent with your home learning relating to dividing by 8. Just a quick thing about this. When you're asked this question about 40 kilograms of potatoes, you might be able to solve it in your head. I'd like to see a number sentence if you can. Or you might do, like they've done in number 4, a bar model. Or you might do a picture. However you want to do it, it'd be lovely to see you sorting it through with a bit of an image as well, with understanding how you've solved that. So how will you solve that question? I can't wait to see. Do you notice anything about the numbers that do divide by 8 exactly? Is there a pattern to them? Is there something you notice about when you add the digits together? Is there anything you notice about the number that's in the ones value? See if you can spot anything. Love to see your input, guys. Thank you for listening so well today. See you all soon. Bye-bye, year 3.